Good morning. Uh-oh, now I've got the hecklers here. Welcome, everybody. My name's Aaron Staley, and I'm the Executive Director for the National Defense Cyber Alliance. We live in a world where we're a very open society, the ability to create, innovate, and just be out there and build without restriction. Unfortunately, our adversaries don't have that openness. They have a very closed, security-focused. So in the United States, convenience is everything. We plug in devices at a rate of 127 devices per second. And Nicole Porwath, in her book, This Is How They Tell Me the World Ends, if you haven't read it, you should, talks about that every part of our lives, the grid, the DIB, every piece, is now connected to the web. And along that journey of automation, we haven't even stopped to think about the fact that we've created the world's largest attack surface. So the NDCA is a public-private partnership. Skip forward here. Created by the FBI, the FBI, DoD, and intelligence customers that supports the DIB, the finance communities, and the biotech environments. For the past 7 years, we have built industry-leading platform that provides cyber threat intelligence in a multi-tier environment to the nation's most sensitive companies. The NDCA platform takes in external telemetry and log data that enables threat hunting, not only across individual companies, but across sectors to find commonalities. This is very important, like load-bearing or APT hits. Our organization supports 400 partners, 47 different field offices. Sure I got the right thing. We do 50 briefings a year across 7 different sectors. Last year, we identified 410,000 separate events, supporting 189 partner notifications and 29 threat sets. Clearly, the National Defense Cyber Alliance has a national security mission, and to enable that mission, we have to work with companies across all size, scopes, and complexities. But how do you build a methodology and a data model that allows for various data sources, formats from companies across a myriad of infrastructures? Problems that are solved with Cribl. I'm excited to introduce Micah, who leads our cybersecurity architecture and engineering, to go through the NDCA select cyber solution set and leverages Cribl into the NDCA environment.
Thank you, Aaron. I will go back a couple slides. We will talk about agenda, and we're hoping really to just kind of give you guys kind of a background look at how we've done what we do and kind of tell the story, how Cribl has really helped us, enabled us to work in a way that we can function. So we're going to go over some of the challenges. Everyone loves to talk about the problems. We're going to talk about some of the problems we had, talk about what our needs for when we were looking for solutions, what were the needs that we needed that tool to work through. Then we're going to talk about some of the things we do specifically kind of unique, at least we think it's unique, where we have some validation built into our pipelines. We're using threat intel, the impact that Cribl has made on our processes, as well as then looking forward to what we think or hope to accomplish going forward, as well as some key takeaways from this presentation. Like I said, my name is Micah. I'm a security analytics engineer supporting the NDCA. We're from Huntsville, Alabama, which is Rocket City. So the space theme of CriblCon, we thought we should put in some movie references to our presentation. So see if you can find some of those as we go through this. Very first off, we're just going to talk about our problems, the challenges, the things that we had to work through. When we get data, we aren't a single organization where we can just connect stuff, trust everything, good to go, plug in those connectors. We have none of that. So we actually have to work on an existing data transfer mechanism where we receive that data. That was just the process we had to work with, something we had to use. So all of the data we bring in is coming from outside entities, and it's all coming in as files. So leads us to issue number 2, data as files. Logs are great when you can stream things in, when they're the format you expect them to be, when everything's machine to machine, that's awesome. When humans get involved, it gets a little tricky. So that's where we work in. A lot of the issues and problems that we see is because there's a human there. They are either uploading data, they are either modifying data, they might be changing things. Some of the challenges that we have to look for and identify as we get that data to be able to trust that it's worthwhile and good data we can use. Many structures, the data comes in. So we are getting CSV files, JSON, syslog, TSV, W3C. If you work in data, you know that any data format that has a header is going to be a lot different than data that will have the event names or field names in the event itself. has to be parsed differently, has to be looked at differently, things like that. Also many different unique formats. Like I said, we have 400 some partners, so we see more firewalls than probably you want to see. Cisco alone, we have about 5 different types of formats, because Cisco can't even agree on what their log format standardization should be. So we see that all the time as well. Some of our other problems that we had was slow data onboarding. It would take us 2 to 3 weeks to onboard data. Most of our job is just onboarding data from, again, all these different companies. So that was a big issue we had seen. We have multiple destinations this was going to, so we had to work through how do you route data intelligently to your different destinations. And for us, because of that emphasis on files, people are doing stuff with it, we really had to work through identifying bad data before ingest so that we weren't messing up or polluting kind of the destinations that we had that data in. We could receive anything, again, as files, like we could receive PDFs, we could receive images. What we were receiving was not just a normal expected log file. So there was a lot of validation things we had to put in place to make sure that we weren't really just messing up and polluting our data. Onboarding those new data types, things that like all of us have worked through, enriching, normalization, transformation, things like that. Of course, a lot of common problems. So this is the before. This was before Cribl. This is by all means ancient as far as today's terms. But we had a full-time person manually looking at files that were uploaded to us. They were seeing if it's something that is already in a current accepted pipeline. Is it something that we already have parsers or formatters for? And then they were moving those files to certain locations where a Splunk forwarder would take it, change it from a file to an event, put it into our destination. They were doing that manually. It was awful. It was the worst job in the world, as you can imagine. Looking at files all day long. Is it okay? Is it not okay? Will it go good? Putting it where it needs to be. As far as the multiple destinations, we had to copy data manually. So how long it takes to copy folders. Well, imagine doing that across scale. Half your day, you're just looking at that green bar going like this, waiting for copies to happen. Also, not a fun job. And then looking at data, if it's files, you have a problem where if someone uploads you a 10 gig file and you open up in Notepad, it's going to crash immediately because Notepad will not like that file for you. So a lot of working through heading files, looking at that data, trying to make sure how can we see it before ingest, before we actually analyze it. A lot of .conf files. Again, we were working in Splunk, having to make sure that everything would be parsed properly. Again, just issues that we saw. In the last one, this would take us kind of weeks to onboard the issues and then find problems. Something we've been able to do with Cribl is proactively find those problems before we actually onboard the data so we can fix them, not find them maybe 3 weeks in advance, 1 year down the road, something weird happens, making sure you can identify ahead of time those issues. Here is the kind of the other things we talked about, the process. So you review those uploaded files, you're copying it to one of 20 different path destinations depending on the source type of that data. You're testing, looking at the problems, trying to backlog, okay, we have these issues we've seen while onboarding new data sources. Again, sending to multiple destinations, copying data, all problems that we had. It would take us a long time to do that. So we came across Cribl, and we're like, wow, this will be great. Really all we do is look at data, change data, and try to get it where we want it to be so people can use it. This sounds like an awesome solution. So some of the things we really use in Cribl, as far as the capabilities that it provides, we'll focus mostly on stream today in our use case. But what it's going to be is chained pipelines, packs, and then knowledge lookups. I will have some, with the chain pipelines, we'll talk about that as well. That can get crazy. So we want to level set that expectation. Don't go crazy on chaining stuff. But it's a very useful tool, something that we use for our validation. Packs, you guys have heard about it probably most of the weekend. They're awesome. Help you stay organized very well, especially when you have a whole bunch of different pipelines, a lot of sources, a lot of destinations, things like that happening. And then knowledge lookups. If you do or are a Splunk user, you're probably familiar with how this works. If not, it's a great way to enrich or correlate that data. So the needs that we had for a tool when we were looking for something, a solution, is that we needed to be able to normalize our data formats quickly. Again, it's something Cribl can do very easily with your pipelines. We also wanted to be able to see, okay, now that I changed the data, can I see it quickly before I actually have to ingest it, look at it that way? Again, that's something with the samples in Cribl, super easy. Make the pipeline, put in a sample, click like apply, and then you can see the changes. So that was something that was really big for us, saving time on testing, saving time on onboarding, saving time in those manners. Multiple destinations. Instead of having to copy files manually, now we can use an output router and we can send things to S3, we can send it to Splunk, we can send it to whatever destination we care about based on the data that we have. Very simple, very cool. Again, organization, when you are working on, you have maybe you're a big company, you have 10 different units, you have HR, you have compliance, you have security, everyone's data is differently. Being able to organize that well is very important from a company, from an efficiency standpoint. We wanted to be able to enrich our events before ingest. So things like GeoIP enrichment, we actually put that data, we put it in each individual event itself, because there would be times where we would want to go back a month, 2 months, 5 months in time and look at data then. And if we had to use the native kind of GeoIP functions of your SIEM, it's going to be looking at right now. So we wanted to make sure that we had that enrichment at event time for that information. So most of the data we actually do is we are enriching it on ingest. Again, that will impact your size and volume. So if that is a concern, that's something you need to be thinking about. That's just something that we do, make those searches a little bit quicker as well. Then we really wanted to be able to find bad data quickly and be able to look through that bad data. So we built chain pipelines that actually go to what we consider an invalid index. So we are able to monitor all data that doesn't match our expected good data limits. They send this location that we can monitor, we can look at, we can figure out, is something happening there? Is it good? Did our regex fail? Is the event bad itself? Maybe the headers are incorrect with what the data is within that header. Things like that you get in data when people are kind of changing things and being involved there. And then we also wanted to have metrics, ways to look at the trends. If we have a company that sends us data consistently, they send us data every hour. If that just stops, we want to be able to identify that, not just 3 weeks in advance when we got no data from you. We want to identify that as quickly as possible. So the metrics feature in Cribl has been something we've been able to implement, something we're able to use quickly, be able to find that stuff usually within the day. Here's a real picture of me when we identified that Cribl could handle the data decay that we saw. We were like, this is great. We don't have to deal with issues of data, issues of changes. Your regex changes, again, the vendor changes the format. They added a new field. They did something that broke your stuff. That's something that we've been able to use Cribl to help us resolve that problem, handle it a little bit better than just someone by chance or luck finding it weeks down the road. So our validation process is sort of kind of twofold way this happens. The problem, of course, data changes over time. Regex fails, and then if you have humans involved, human errors happen all the way. I could probably add AI errors to this at some point. That's going to be a thing as well that we're going to want to be able to identify. So we needed a big solution to that. Again, our problem with the data we get, it's never machine to machine. It's never going to be fully expected formatting. So we are having to validate all the data we bring in, make sure it's good. So how we do this is that we have a strategy where we are dynamically handling any changes that happen, hopefully to prevent any of that data decay. This is going to be focused for us on the data structure type. So we bring in data, we will look, is it a CSV file, is it a JSON, is it syslog, TSV? Based on that format, we're going to send it to a specific route. So we'll have it 3 types of routes. We'll have a generic, so generic data format. We're going to have a level 2 route, or level 2 pipeline, I should say, which is going to be kind of the golden pipeline or the expected parser formatter of that data. Then we're going to have a level 3 validation pipeline. Those are all going to be chained together, which I will have some pictures to help explain that. It's a little confusing. So hopefully the pictures don't confuse you more. Some of them might a little bit. Then at the end there, we do have a way to, any data that doesn't match our validation or isn't what we consider good data, we're sending to a location for review that a person could go and figure out, was this an us issue? Was this just a bad event? Was it a bad product that was sent to us? What was really the problem with that data? Why did it not match what we think? So how it starts all on our routes, like I said, we are routing based on structure of that data. So we'll go give it a source type based on ingest and from the Splunk forwarder initially. Okay, we know what it is, we know the file, we know the structure, we know how we should parse it, how we should look into that. We'll go down that line. Everything will be tied to a level 1 pipeline. That level 1 pipeline, again, is just specific to the structure of the data. This is where it gets really fun. Here we have a bunch of chains. Now, with these chains, they are not chained to each other. So it's not like you see 10 chains here. All these will be chained to a certain level 2 pipeline. So again, this is our level 1 pipeline. This is where the structure for this one, it is syslog. So anything that we consider to be a syslog data will come into this pipeline. And this is where we're going to look, OK, which level 2 pipeline or expected data that we bring in is it going to go into or match? This will typically be based on certain ones will be vendor specific. You have, OK, this is what a Palo log looks like. This is what a ASA log looks like. This is what Fortinet, whatever type of expected data you have will go there. If not, we have some custom ones that will be built for certain partners. Again, all companies we work with, they might change data themselves, and then they send us the change data. So we don't always get the expected vendor kind of default format. We might get whatever format they changed or they decided to add. We might get just a CSV file of 10 fields with events, something like NetFlow, something like that. So there are certain ones that won't fit the native there. And then we also will have a column for all of them you see underscore or double underscore matched. So every level 2 pipeline, we are going to set matched to true. So if it is matched, it will not match by default anything else in this level 1 here, as well as if it doesn't meet anything, that's where it's going to go to that unmatched, basically, chain where, OK, now we figure out why did it not match this? What is the information there involved? Here is going to be our level 2. So we'll use Palo Alto, for example. Here in this level 2 pipeline, one of the first things we're doing, we're setting that underscore match to true. Again, so it doesn't, once it matches that, OK, yep, we know what it's parsing. We know where it's going. We'll set it to matched. Now it's good to go. Then we'll just follow the rest of that pipeline with the normal extractions, enrichments, things that we're doing there. And finally, we have our output router. So this is how we determine, OK, if our data is good, we're going to send it to this destination. If it's not good, we're going to send it to this destination. If it's something that we're tested, it'll just go to a specific index that we're looking at there. And if it's not matched at all, that means we're going to send it to our test index or our invalid data index. We're going to look at it manually. We're going to figure out what happened to that data. Why is it something that didn't match what we got? Is it also maybe a completely new format that we've never seen? I'm sure you guys don't have this problem, but we have the problem where people will send us stuff that we don't tell them they can send us. So we get data that's completely different than what we normally take in or expect, and then we got to figure out what to do with it. So our way to figure out that or to identify when someone sends us something new that they don't give us any warning, they just send it, hey, you guys take logs, here, logs. Of course, that never happens, but for us, it does sometimes. So we have to figure out, OK, they send us something new. We want to find it. We don't want it to get lost. How do we check that data? This is the process that we've built in to be able to validate our current data, as well as find and proactively identify when stuff is sent to us that isn't expected. What do we do with it? How do we handle it? That's kind of a process that we've built, put in place. Our estimates of how this has helped us or impacted us has saved us about 75% of our work time in just onboarding new data sources. Again, being able to early figure out something new is coming, that the event's not being dropped, that it's not being lost because it didn't match a regex or something like that. About 83%, so we went from 2 full-time people to about 30% for 1 full-time reduction in the data maintenance tasks. So just identifying that data, correcting issues, figuring out what changed, all that type of stuff. All the tasks that aren't as fun but are necessary to make sure your data is clean. If the data is not clean, that's where you have your analysis problems. That's where your products, your customers will find issues in. So it's very important to make sure your data is good. And then as far as changing from kind of like a manual to a real-time task, we've been able to highly decrease the time it's taken us to find as well as correct that invalid data. Our efforts, really. So anything that doesn't match, anything that's different than the expected data. So now that we're talking about getting that data, all the challenges we've seen, how to actually just make it good. Well, now we want to use it, right? Now we actually want to be able to detect threats. Now we want to find stuff. So some of the stuff that we've done is to incorporate commercial CTI through Cribl. Ultimately, we bring it in from Splunk TAs. A lot of vendors will have ways you can bring in that intel. We bring that in. We'll send that in as events through Cribl, send that into our SIEM as well. We also have a MISP server that you can bring in through API collector. You can bring in the events and the attributes of that, the REST API source. We also do event enrichment on ingest. So things like GeoIP, ASN, ISP, organization, everything tied to that value of that data. A lot of data we work in is going to be network web focused. So that's why we specifically look into these events, look into that context. And we would do that through 2 different methods, kind of complementary. We both have lookups. from Maximind, which you can actually do this all for free, have Maximind lookups that are able to enrich most of that information. And then we have a Redis database that does the organization. There is a current, I think it's a size limitation where you can't have a lookup and in the Cribl event included with that byte, the byte character limit, we'll say something like that. So we have a Redis database that we are currently also querying for that information. And as events are brought in, it looks against that database and it'll add the context to that event as necessary for us. So looking forward or looking to what could we do, how could we improve this? Like we have, again, we've said some of the stuff we've done, we really incorporated about a year and a half ago. So we're constantly building, we're constantly growing. So things that we have considered, being able to summarize those NetFlow events. We all know if you have NetFlow, if you have VPC flow logs, those things are massive. How can you use those? How can you use those well? Cribl has an aggregate function where you can summarize those events. So say the same traffic traverses from one location to the same destination 80 times within 2 minutes. Well, you can summarize that down into basically one event where you have the listing of how many times it happened, the same information. That's one way, one thing you can do to save data costs or storage costs, as well as just work with some of those very massive data source types that you will have. We also are considering having a lookup for threat stuff based on really in-flight. So if we know, hey, we know that these IPs, these actors are bad, we have our own like list of intel, we can make that a lookup. We could compare stuff upon ingest in Cribl to that. We could add a field that says, hey, known intel match, something like that. You could have a field where then you can sort in your SIEM, you can sort on anything that has a known intel match field being yes, and that would be a quick and easy way you could find information within your events, the things that you would see, be able to kind of filter down that way. You saw in the keynote a lot of talk about Lake. That's something we also are strongly considering looking into for just storage and replay of events. If there are, again, those parsers, those things that change and you do want to replay your data, you want to go from just storing it somewhere that's maybe we want to replay it or we want to add it as necessary. Maybe you don't put everything into your SIEM all at once. Again, wouldn't recommend that. But say you put certain data into your SIEM. Well, now we find that we want to actually analyze or we want to investigate this information more. Let's bring some more data from that. In our case, it would be from that partner company. In your case, it could be from that endpoint. It could be from that host. It could be whatever. We want to bring that data in now to analyze it in our SIEM. That's something you could easily do with Cribl Lake and storage, being able to replay that data into it. Last point here is looking to have a stream capability for our partner. Like I said, we have been working for some years now on this secure file transfer mechanism, but we all know, or at least I know, that data and logs don't like files. So if you can stream things, really the better that will be for you. So we're looking into potentially having either a lake or just a bucket destination. Partners can send the data to us. We can use Cribl, pull it straight from that bucket, be able to ingest it that way. That will hopefully cut out some of those human errors, as well as just to provide the scalability for us. For most companies, this is probably easy. It's a no-brainer. But just for us, because we have to work with 300 or 400 different POCs, different companies, different organizations, working through that process, working through how would you make something like that secure, as well as just operationally doable. There is a lot of considerations to have in place there. So one thing about Cribl that we found that we want to just really point and highlight to you is that if you can dream something up, you can probably make it happen. You'll see within Cribl, within people you talk to, there are multiple ways to solve the same problem. So you might see, hey, I came about it this way. You might come about this way, and that's all something you can do. So definitely something recommend. Hey, if you are looking, talk to people, look at what's out there. Maybe you want to validate your data. What we did, it could work. It could be awesome. Maybe you have an even better way how you're doing that, how you're being able to figure out what is the good data, what's clean data, what's useful. And then here are just our takeaways. We will have a couple minutes for questions. So if there are any questions, we can absolutely talk about that. The key takeaways we really want to think about is that clean data is important. Kind of like Clint said at the keynote, things like your schema. Okay, are you OCSF? Are you ECS? What is your schema? What are you mapping things to? That's very important. Being able to build for efficiency and scale. You guys probably have heard scale for a couple of years now. That's all something we have to think about, especially with the onset of AI and AI data or telemetry that will be involved there. Being able to plan ahead of time, what is something that will scale, thinking through those problems. Understanding also how the data will be used and then by who prior to making these changes or transformations to the data. The quick example, we were onboarding some data. We're like, hey, this will be great. We just need this value, need this information for it. Then we turned out that when we gave it to our ultimate customer, They're looking at the data and they're like, hey, this doesn't have what we need. This is absolutely not how we would use the data. We had made assumptions on how one would use that type of data for what they need to do. They had completely different thoughts on how they wanted to use that data. So knowing that stuff ahead of time before you go through the work of having to build stuff is very important, very critical. And then last one, yeah, just dream big. Figure out what you want to do. You can probably make it happen. There are ways to do it in Cribl. There are ways to do it in all these tools. So that's definitely something to consider, something to think about, and know that, like I said, it is possible. Again, what we did, we do have a lot of kind of use cases that don't apply to organizations based on the bringing data from outside entities, but it does apply when you consider, okay, maybe your outside entities are just your different organizational units, they're your different teams, the things that people really should be talking about that no one seems to communicate about, no one seems to talk about. How do we make that happen? How do we get our data to a central location that can work for people, work where they need it and how they need it? That's all we got. We have a couple minutes. So yeah, if there are any questions at all, feel free to ask. Go away. Yeah.
You mentioned that you use metrics that monitor.
Yeah. So the metrics that we are tracking are mostly going to be volume related. So, okay, we're looking at the data ingest, we're looking at the amount of events, we're looking at the size, like gigabytes, terabytes, whatever you're looking at, stuff like that. We are tracking, the way we index our data is going to be each company more or less will have their index. So we will have a metrics that will be built into, I believe it is a post-processing pipeline. So all the data that we have is going to go through it to our destination. Then from there, we are tracking those metrics. It'll, again, like I said, it'll be volume-based. So we're looking at what is the volume from that, and then we're sending that metrics data to our SIEM as well. So we can actually look more so in real time, have searches every 5 minutes looking at bar graphs or whatever you want of the data, seeing what the changes are. And that has saved us for instead of having to basically count or group all the events themselves, you have those metrics, which is a lot lower count of volume. So instead of looking for, you have 200 indexes, look across all that data, bring it out by company, looking for the counts per day, per week, whatever. With the index or with the metrics, it might be like 100,000 events as opposed to like you're looking at 300 million events. So that's something that we found where that will actually help you when you're using your SIEM, when you're looking at that, to correlate and have quicker queries, quicker information to get to you.
Have you guys looked at the CPU credits used by having literally all the logs go through your chain pipelines instead of taking your routes, the most used routes, starting those at the top, trickling down? So let's say 90% of your logs, let's say, are Windows event logs. You have that route and pipeline at the top, so they don't have to go through all the other routes that take CPU usage, while your chain pipelines sound like every single log is going through, let's say, 20 chain pipelines. Doesn't that use more CPU credits?
So yeah, in our case, it won't go through all 20 because it won't match anything. It'll just match the one. But you're absolutely right. You do want to have the ones that you expect to like match first. It would be beneficial to go at the top to go through that. We are all on-prem, so as far as the credits, it's a little different how we are looking for the usage and stuff like that. We don't have some of the cloud costs and stuff like that looking at it. But you're absolutely right. That's one thing I definitely would recommend to do. Put the most voluminous stuff at the top. In our case, because it's looking for a matched volume and it's looking for the regex match, I do understand that what you're saying, that it'll regex match everything. So you are going to have that value or comparing against it. If not, comparing against the bottom one, comparing against the one below that. So that is definitely something you should do. We do have occasional times where partners send us data that we have to modify once before it gets to what we call the level 2 pipeline. So we'll have a partner-specific pipeline where they might use, we'll say they have like Palo, but instead of Palo syslog, they send it to us in a JSON. So then we have to take it from the JSON, and we just then will basically turn it, or we'll pull out, say, the underscore raw field. That's actually then the normal event. And then we're going to send that to the level 2 one, which will be the actual golden pipeline of Palo. So some of those, sometimes we have situations where we have needs to give a company or a partner a one above before all the goldens, only because we have to do almost like a pre-processing change to make it match what we expect it to be. So that sometimes happens for us. But if you can expect what the data will be and you know that's the format, then that's absolutely something you should look into.
There's a lot of talk about redacting data. Do you have a way to redact it after, like, it's been there 30 days? Like, this is data that we need, like, it's real-time data, it's in there, but then when we put in deep storage or tier 2 or tier 3, then it gets redacted. Like, first it's not, we use it, and then once it gets past, let's say financial data. After 7 years, I don't need it, but they still want parts of it. So I want to redact things that legally I don't want, after 7 years in deep storage, but I need that same data in not deep storage.
Is this already in an analysis platform where you've sent it past Cribl, it's stored somewhere that you're looking at? Like, one way you could do that, if you replay data in Cribl, you could then redact everything that's replayed, sent to wherever it needs to go. If it's already in your destination, I wouldn't be exactly sure if you could make that happen.
Okay, this was asked to me, and that's why I had no idea.
Yeah.
So it was like, hey, I got this social security numbers. I'm an electronic health record. I got your HIPAA data. Well, I only need it while you're there. Then I'm going to redact it and send it in. Just, I can still use that for research and development if I get rid of the 18 things that are redactable for HIPAA.
Yeah.
So.
Yeah, it would kind of depend, where that data is all lives at, I guess, and the ability to redact it then. With the replay function, you can absolutely set, basically you would just take it from your cloud, wherever you're storing it, and you'll just run it back through your pipelines and everything. Let's talk afterwards, and I'll figure out what you're working. Yeah, for sure. Yeah. Yeah, looks like we're about out of time, but if any other questions, feel free to find us. We'll be around. Hope you guys have a great rest of your day. Thank you.